Okay, I lied. Um, I think all we're going to do today, because you guys worked so hard last day, and this is going to be basically a math time. I think we're just going to do the math today, and I'm going to allow you guys to use the rest of your time catching up if you need to, or doing coursework in other subjects. But let's start by looking at the homework that I did ask you to do. So it says, what determines the amount of resistance offered by a resistor? Well, types of material is the number one thing, but also the length and diameter, and in some special cases, the temperature as well. And we talk about that later. Ways that how resistors are made. The first one, I've got these a little bit out of order. Some of them are made of carbon, okay, because carbon doesn't conduct electricity well at all. The other way is to take metal wire and wrap it around something that doesn't conduct electricity itself, such as ceramic or plastic tubing. So those, I would say that those are probably the two ones that are most important. The other one is about temperature, and that's where semiconductors come in. And semiconductors play into both these questions. So I mentioned here that if the resistor is made of a semiconductor, then that is where the temperature comes into play. And you say, well, what's a semiconductor? Well, go back to your periodic table and you remember that there's that magic stairway that separates metals on the left from non-metals on the right. And there are elements that live on either side of that staircase that are considered semiconductors, like silicon. Silicon is probably the most used semiconductor ever. You've probably heard of the terminology of Silicon Valley in the States, California. That's where really the birthplace of a lot of our technology came from. Anyway, then on the other side, I asked you to do question 9. So I'll just show you my rendition. So the first two digits are our first two bands are talking about the first two digits. The third band is talking about how many zeros you add. So 6 and 7. Black is a 0 additional, so it's just 67. Gray is 8 and 8 with 3 zeros, so 8, 8, and 3 zeros, so 88,000. Brown is 1, red is 2, so that's 1, 2. Green is for 5, so you can see I've underlined 5 zeros, so 1.2 million ohms. Green is 5, black is 0, and then 4 additional zeros, so 500,000. 1 for brown, 8 for gray, and 3 zeros for orange, so 18,000. So that's the easy part. I hope you had fun with that. Okay, so cool. Let's start. Let me do the first one for you, and then I'm going to get you to do the remaining ones after I do them. Okay, so let's look at question number 3. An electric hot plate in a science lab uses a current of 8.5 amps. So that's current. When it's plugged into a 120 volt outlet, so this is your wall outlet. This is voltage. So, and they're asking you, what is the resistance? So, resistance, I have my cheat sheet right here. So resistance is equal to voltage divided by current. So resistance is equal to voltage divided by current. Resistance is 120 volts. Current is 8.5 amps. And plug and play. 120 divided by 14.11. I usually go to two or three digits in here. If you just wrote 14, I would be happy with that. Okay, now I want you to pause. Do this one. Start by identifying the different pieces, then select the right form of the equation, plug in the values, and calculate. Go. This one's not too bad. 5 times 24, or not 24, try that again. 5 times 2.4 equals 12 volts. Okay. Okay, pause again. Do number 5. When you're done, come back. Okay, so the equation we're going to use is I, because we're looking for current, is equal to V over R. Voltage is 9 volts divided by 500,000. So, trusty calculator, 9 divided by 511 equals mine is giving me in scientific notation. So there's a way. I'll have to use my okay, so this 4 zeros. So this comes up to 0, 1, 2, 3, 4. So there's a decimal. There should be 4 zeros and 1 8. Now you want it to do this in milliamps. So what you're going to do is now you're going to move this 3 spaces to the right. Okay, so this is going to go 1, 2, 3. So they want it in milliamps. Answer in milliamps. So it is 0.018 milliamps. So that is the answer there. Okay. So this is interesting. Okay. the resistance over at screen is 1,000 ohms. How much current would go through you if you touch the terminal of 9-volt battery with red hands? Answer in milliamps. Pause and go. So same routine, resistance. So current V are 9 volts times divided by 1,000 ohms. So actually it keeps doing that. So this is comes out to 0.009 ohms. Same deals here. They want it in milliamps. So move 3 spaces. 1, 2, 3. So the answer in milliamps is 9 milliamps. Okay? Okay, page over. Woohoo! 2 more. Yes! I love this stuff. This is fun. A toaster uses a current of 4 amps. If the resistance is 27 ohms, what's the voltage? Pause and go. .108 volts. Same deal. Label V equals IR. I know because I've got this right here. So V equals IR. Bam! Just like that. Figure 5 on page 319. A toaster uses a current. Figure 5. Shows a light bulb connected to, I'll show this to you. Okay, so that's what they're talking about there. So it says, I'm going to just turn around here. So it says, when the switch is closed and an ammeter measures the current is 252 milliamps, what is the resistance of the bulb? Oh, okay. So that's just another problem. You don't even need this diagram because all the information is here anyway. So pause, plug and play, be careful, this is in milliamps. Change it to amps. Go. So 1.2 volts divided by 0.252 amps. So 1.2 divided by 4 4.76. So you're done for the day. Again, use this time to catch up if you need, and otherwise I want to start fresh with when we're talking about resistors in series and parallel circuits next day. Okay? Awesome. Thank you. See you the next day.